Let's look at the classification of proteins based on function. What is this protein actually doing? We have different types of protein. So please, when we mention protein, your mind should not run to dietary protein, protein found in your diet. Your mind should not run there first. We have different kinds of proteins. Now, based on function, the work that protein is performing, proteins can be classified into one, structural proteins. So proteins can be classified based on structure. The structural proteins, they are found as part of the structural framework of the body. They are resistant to digestion. They are strong. So they form part of the structure of the body. And you agree with me that what class of protein fall under this? Fibrous proteins can fall under this, right? Because fibrous proteins are strong, rigid. They are not soluble. So structural proteins are those proteins that form part of the structure of the body. Example, keratin. Where can keratin be found? The hair, right? Where else can it be found? The nails. Forming structure of the body. Collagen. Collagen is found in the bone, found in tendons, found in joints. Collagen. And it forms structural components of the body. So structural proteins are those proteins that form structural frameworks of the body. Enzymes. You agree with me that all enzymes are what? Proteins, right? Enzymes are proteins, is it not? And enzymes are called organic catalysts, is it not? Made up of protein. Enzyme is a topic which we are going to talk about in this course. Now, enzymes are also called catalytic proteins. Why? Because they catalyze biochemical reactions, right? They hasten, they speed up biochemical reaction. Let me even use one example that outside the human body. Do you know that if you are cooking meat and you want the meat to become soft very fast, that if you cut pawpaw leaf and you put on the meat, that will make the meat tenderize very fast? Do you know that? Because there's an enzyme in that pawpaw leaf called papain, and that papain found there can help to tenderize the meat very fast, hastening the reaction. Do you also know, apart from the biochemical one, that if you are cooking beans and you want it to be soft very fast, that if you put iron spoon inside, that the beans will become soft very fast? Yes. I don't give you updates now. So enzymes are catalytic proteins. Examples of enzymes. We say, what are the functions of enzymes? Catalyze chemical reactions, right? Good. We have so many of them. Hexokinase, pepsin, glucokinase, which there are just many. There are many. But when we get to this topic, enzymes, we talk more about that. The next class of protein here is the transport proteins. Transport proteins are involved in the transport of molecules within the cells and throughout the body. Transport proteins can do that. They are like vehicles for transport. For example, hemoglobin. Hemoglobin is a tetrameric protein. It has 4 binding sites. And the function of hemoglobin is to do what? To transport what? Oxygen. Hemoglobin is part of the red blood cell. And as a part of the red blood cell, its major function is to transport oxygen around the body. Now, you heard of the case where they say a family owned joint passed my neighbor and put in their house, and it killed all of them. You agree with me that carbon monoxide comes from that fume. Now, carbon monoxide, this is how hemoglobin is. This is how I'm using this as an illustration. Hemoglobin has 4 binding sites, and oxygen can bind here and be transported. But now, hemoglobin has affinity also for carbon monoxide. So by the time carbon monoxide comes, carbon monoxide will displace all this oxygen, and you discover that hemoglobin will be transporting carbon monoxide now instead of oxygen. And even if carbon monoxide gets into the body, carbon monoxide, we want to be oxidized to carbon dioxide, right? We want to be oxidized to carbon dioxide. So it will just be taking all the oxygen, and vital organs will be deprived of oxygen. Hemoglobin cannot transport Oxygen again. No oxygen to even transport. And so they die because of lack of oxygen. So hemoglobin is a transport protein that is involved in transporting oxygen from one part of the body to another. All right, good. So that falls under transport protein. Now, protective proteins or antibodies protective proteins are those proteins that protect us from antigens. Antigens are enemies. Antigens can be viruses, can be bacteria, germs, and the rest. Antigens. So the function of antibody or protective proteins is to fight against those antigens. Now, the white blood cell, the major function of the white blood cell is to protect us, to fight against diseases. Have you ever had injury and pus starts coming out? Anytime pus start coming out from your injury, that is a clear sign of infection. That is a clear sign that there is an infection on that site of injury, because white blood cells are there to fight against the invading microorganism. But if white blood cells are destroyed, they turn to pus. So that pus is actually white blood cells that have lost the battle. White blood cells that have been destroyed, have been killed. The white blood cell is a soldier there trying to protect you, but invading Boko Haram destroyed that part. So that's that. So protective proteins or antibodies are there to fight against antigens, and generally antibodies are called immunoglobulins. There are different types of immunoglobulins: immunoglobulin G, immunoglobulin M, and the rest. But that is beyond the scope of this, so we'll leave it there. Contractile proteins. The first thing that should come to your mind anytime you hear contractile is movement. So contractile proteins are proteins that are involved in what? That assist in movement, right? That aids movement. And how do they do that? They work with the cytoskeleton. Now, protective proteins or contractile proteins, example, actin and myosin. When we talk about the mozo as a topic, not in this course, but mozo is a topic. For those of you in BCH, you do it in BCH 312. Mozo, you see how all these things are happening. That's when you learn more about the functions of actin and myosin. But for now, just know that actin and myosin are contractile proteins, right? They are involved in movement. Storage proteins. They store nutrients. They are involved in storing nutrients in the body. For example, ferritin. Ferritin is involved in storing iron. Remember, iron is Fe, right? It's involved in storing iron. So ferritin is a protein that stores iron. So storage proteins store one or more nutrients. All right, so basically, this is a classification of proteins based on their function. One cheat of answering exam question, even if the question does not say give example. As you write, give them example. As you write on structural protein, give example. Give example. That will convince the examiner or the person marking that this person knows what he or she is doing.